Hello and welcome to this section of the Algebra Tutor. In this section we're going to talk about zero and negative exponents. So in the previous section we did a lot of work with exponents, how to simplify expressions that have exponents in them on the top and the bottom of a fraction, or if they're multiplied, or any number of things. We talked about how to handle that. Now we're going to expand and talk a little bit more about what happens if you have a negative exponent, which we briefly talked about. We're going to talk a lot more about it now. And also, what if you have an exponent that's just zero? So it's kind of like, first when you do exponents, you talk about regular exponents like 1, 2, and 3, and so on. And then you talk about zero and negative exponents because there's a couple of other things to think about. But none of it's hard. Let me write down the important stuff and we'll work a lot of problems to give you confidence. So the first thing I'm going to do is put on the board something very important. If you have anything, in this case I'm going to represent it by x, but anything raised to the power of 0, you're always going to get 1, right? Always. If you have 3 raised to the power of 0, it's 1. If you have 19 raised to the power of 0, it's 1. If you have negative 39, if you have pi raised to the power of 0, if you have anything raised to the power of 0, it's 1. That's just a definition from a mathematical definition. You know, a lot of times in math, people who developed algebra, they had to make certain assumptions and define certain things in order for the rest of it to make sense and to build on those initial assumptions. The same thing is going on here. It may not make a lot of sense that you raise something to a 0 power and get 1, but it's just a definition. So you have to always, keep that true. A lot of students will say this is equal to 0. I know it might seem like it's equal to 0, but you always have to write those things equal to 1. All right. The second thing I'm going to write down, I'm going to leave these on the board, is that if you have any kind of variable or whatever and it's raised to a negative exponent, so this exponent, it doesn't matter what it is, I'm just going to call it negative x. It's the same thing as saying 1 over y raised to the positive x. This is so very important. A lot of students will look at negative exponents and get weirded out by them. How can you have a negative exponent? Because when we talk about exponents, we talk about it being, things being multiplied together. How do you do that negative times? Well, what's really going on is if you have a negative exponent, it's the same as 1 divided by the same thing you have here, but to a positive exponent. So negative exponent basically just means you move it down below the fraction bar, below, if there's nothing there, then you just move it below a 1. If it's involved in a larger fraction, you just move it downstairs to the bottom of the fraction, and you make the exponent positive when you do that. So these two things are so important that I'm going to actually leave them on the board for a few minutes while we do a couple of our initial problems. All right, so let's start small. Let's say we have 2 to the power of 5 multiplied by 2 to the power of negative 2. Again, a lot of students look at that and say, well, what does 2 to the negative 2 mean? How can that work? Well, we talked a little bit about the fact that this is really 1 over 2 to the power of positive 2. And just to give you an example, 2 to the negative 2, you just move it downstairs below the fraction and make it positive. That's what that's equal to. But for the purpose of trying to simplify an expression, everything is the same as what we've already learned. You don't have any new rules. Here we have 2 is the same, so we can add these exponents. So what we'll have is 2, 5 plus a negative 2, or 5 minus 2 is 3. And this is the answer, right? That is the answer. You just add them together just the way you always do, using your knowledge of adding negative and positive numbers. Now there's another way to do it. Just like I tell you, there's always more than one way to do a problem. And that is to kind of take advantage of what we just talked about here. This is also equal to 2 to the power of 5 times. This can be written as 1 over 2 squared, like that. Which, since this is all multiplied together, this is just 2 to the power of 5 divided by 2 squared, because don't forget, this is kind of like over 1. So when you multiply these things, you'll get this. Now, we've done problems like this a lot in the last section, right? You can say 5 minus 2 will give you 3. But you can also say I have 2 of these 2's down here, which are going to cancel with 2 of the ones that are upstairs. I'm only going to have 3 left. So it's 2 raised to the power of 3. So it's either way you want to think about it. If you want to just go ahead and add the exponents like we've always done, fine, do that. If you want to move this to the bottom and then cancel, using all the cancellation rules that we've learned a lot in the last section, then do that. Either way is fine. You should always get the same answer. So let's continue to build our skills. Let's say we have 3 raised to the 5th power times 3 to the negative 2 power over 3 to the third power. And again, there's many ways to do it. I could add these exponents on the top and then I could simplify, but I want to show you different ways to do things. So let's take this 3 to the negative 2 and move it downstairs. 3 to the fifth times 3 to the third times 3 to the positive 2. We take this negative 2 and we move it downstairs and make it positive. This comes directly from this. Anytime you have a negative exponent, you move it downstairs and make it positive. And that's what we've done here. So on the top, you have 3 to the fifth. On the bottom, you have the same base, so you can add these exponents, 3 to the fifth. So what do you think 3 to the fifth divided by 3 to the fifth is? Well, anything divided by itself is 1. And that's the final answer. 1 is the final answer. Okay? So everything's self-consistent. Everything you've learned up to this point applies to negative exponents. It's just a couple of other things to think about, like moving it downstairs, which are alternative ways to do it. 2 to the fifth times 2 to the seventh divided by 2 to the sixth times 2 to the negative 3. Now I have a negative exponent on the bottom there. So how do you think we're going to do this? Well, many ways I can do it. I could combine these guys here and combine these guys here, and then I can simplify. But that wouldn't be much fun. I'm trying to teach you about negative exponents, so I want to bring that out of this problem. First thing I'm going to do is cancel 6 of these 2's that are in the bottom with 6 of the 2's that are present there. That's going to leave me with 1 2 left over in the top off of this, right? So I can rewrite this as 2 to the fifth times 2 to the first, or just 2. On the bottom is 2 to the negative 3. Okay? So another way to write this is, since I have a negative guy here, I could say 2 to the fifth times 2 to the first times, this is negative, I can move it upstairs, 2 to the positive 3. What I've done here is incredibly important for you to make sure and understand. If you have a negative exponent like we had here on the top, you just move it to the bottom and make it positive. That's how you handle it, to make it positive. If you have a negative exponent on the bottom, you just move it to the top and make it positive. No matter where your negative exponent is, you move it to the other side, either top or bottom, and make it positive. That's how you deal with it if you don't want to be dealing with these negative exponents. So now I have the same base, and I can add these. 6 plus 3 is 9, 2 to the power of 9. And that is the final answer. All right, what if you have 2 times x to the 0 power? What are you going to get there? How do you simplify that? Well, you'll have 2 times this guy. What is x to the 0? Well, we just talked about it. Anything to the 0 is 1, so you'll just get a 2. That's the answer. If you put that in and calculate that, you'll always get 2. The x to the 0 just drops out because it's equal to 1. What if you had something more complicated, like a squared times b cubed divided by a times b to the fourth, and the entire thing's raised to the 0 power? How do you simplify this? Well, you could probably simplify some stuff on the middle and get it nice and simple, but you notice the entire thing is raised to the 0. That means the answer is 1. It has no bearing. It doesn't matter at all what is inside of these parentheses. If the whole thing's raised to 0, it's equal to 1. It doesn't matter if a is 15 and b is 94. It doesn't matter the values. Anything raised to the 0 power is always 1. So that's why dealing with 0 exponents, or exponents that are 0 really, is kind of easy, to be honest with you, because it's always equal to 1. What if you have, just kind of give you a little review here, x to the minus 2. How do you rewrite that in terms of a positive exponent? It's 1 over x squared, right? What if you have 2y raised to the negative 4th power? Well, it's a negative power, so you take everything that it's applying to, which is 2y, and move it to the bottom and make the exponent positive. 1 over 2y raised to the 4th power. And we notice here that we can go a little bit further because we have this guy raised to the 4th power. So over here we can have 1 over, we can distribute this 4 in, so it would be 2 to the 4th power times y to the 4th power. And of course you can go in a calculator and do 2 times 2 times 2 times 2 and get a number, but basically what you have is a number times y to the 4th on the bottom there. All right, what if you have y to the 4th over y to the 5th? How do you do that? We did some of these kinds of problems in the last section. Well, basically on the top you have 4 y's multiplied by one another, and on the bottom you have 5 y's multiplied together. So I know that when I do cancellations, all 4 of these y's can cancel with all of these, and I'll just be left with 1 y left over. So really, it's 1 over y to the 1st power, which is 1 over y. Another way to write that, if you want, is y to the negative 1. We've been talking about this the whole time. Y to the negative 1 is 1 over y to the positive 1. So either way you want to write it's fine. I'm just trying to give you some practice so that you can see that. All right, what if you have y to the 4th power times y to the 3rd power divided by y to the 4th power times y to the negative 2 power, to the negative 2. How do you handle that? Again, there's many ways you can go. I mean, I could combine the tops, combine these exponents here, and then I could combine these, but then I would have positive exponents everywhere, and that's no fun. I want to teach you how to deal with this in other ways. So there's many ways to go, but I notice right away I have y to the 4th on the top and y to the 4th on the bottom. So I know all 4 of these y's are going to cancel with all 4 of those y's. And what I would be left with, basically, would be y cubed on the top over y to the negative 2 on the bottom. And then I notice right away, okay, this is a negative exponent. I can move this up. So I have y cubed times y squared. I make it positive as I move it up. Anytime you have negative exponents, you can move them up and down as long as you flip the sign. Then I can just add these exponents, y to the 5th. This is a good way to solve this problem, a perfectly fine way to solve this problem. Let me show you how to do it a different way. Right? So the original problem was y to the 4th, y to the 3rd, over y to the 4th, y to the negative 2. Well, I can combine these exponents in the top, so I add them because they have the same base. So it's y to the 7th. Here I can combine these because I have y's. When I add these numbers, I just get y to the power of 2. And then I look at this and I realize I have 2 y's on the bottom and 7 on the top. So I'm going to have 5 y's left over on the top. And this is the same exact answer that we got to begin with. Right? Now let me just do one more way to show you how to do this problem. Y to the 4th, y to the 3rd, y to the 4th, y to the negative 2. Right? I don't simplify anything, let's say, in this case. I just immediately move the exponent up here. So I have y to the 4th times y to the 3rd. I move this upstairs, making him y to the power of positive 2. On the bottom, I still have y to the 4th. So I notice right away I can cancel all this with all of this. Okay? And then on the top, I just have y, 3 plus 2 is 5. So notice in all cases I get the same thing. And I'm not going to do this for every problem, but I wanted to do it for this problem to really show you you have latitude. If you want to cancel first and then simplify, that's fine. If you want to, move the negative exponent up there and then simplify, that's fine. If you want to do something else, that's fine. As long as you're doing legal things, you basically can do whatever you want in order to simplify these things. All right, what if you have x to the negative 4 times x to the 3rd, all raised to the 3 power? How would you handle that? A million ways to do it, but I can see that I have x's in the middle. I can add these exponents together. So what I'm going to have, negative 4 plus 3 is x to the negative 1. It's raised to the 3rd power. And again, there's a million things I can do here, but I see that this is a negative exponent. I can make it 1 over x to the 1st power, like this. And now I remember that when I have a fraction and I'm applying an exponent, I apply it to the top and to the bottom. So this will be 1 cubed, and this will be x cubed. 1 cubed is 1 times 1 times 1, so it's 1 over x cubed. And so that's the final answer, 1 over x cubed. There's lots of different ways to go for all of these guys, but you should always end in the same place. So it's actually kind of a good exercise for you to solve them different ways. What if I have a to the negative 2 times b to the negative 3, all raised to the negative 4th power? So I have negative exponents everywhere. Lots of things I can do, but I just want to do it this way. I can't really combine these, but I'm going to distribute this negative 4 in to the exponent. So I'll have a to the negative 2 raised to the negative 4th power multiplied by b to the negative 3 raised to the negative 4th power. So basically I'm just raising each term to the power. And then I remember that when I have a power raised to a power, I multiply them, and that applies to negative exponents just like it does to positive. So it's going to be a, negative 2 times negative 4 is positive 8, times b, negative 3 times negative 4 is positive 12. So it doesn't matter if they're negative or positive. You do everything exactly the same way. A to the 8th times b to the 12th. All right? Now what if we had something like a cubed over a to the negative fourth raised to the second power. How would we do that? Again, lots of different ways to do it. Let's take this negative exponent and move it upstairs. And so what we'll have is a cubed times a to the positive fourth power raised to the power of 2. We just take this guy, move it upstairs, make him positive. Now we can distribute the 2 in like this. You can do it either way you want, or you could add these guys first. Let's go ahead and distribute the 2 in. So we'll have a, 2 times 3 is 6, times a, 4 times 2 is 8. And now we can add these exponents because these are the same bases we're multiplying. So a, 6 plus 8, 14. A to the 14th power. All right, and let's do one a little bit bigger. Let's say we have negative 3 times r to the 4th times r to the negative 3 over r to the negative 3 times r to the 7th, all raised to the 3rd power. Lots of different ways you can go, but the first thing I notice is I have an r to the negative 3 and an r to the negative 3. They're both present in the top and the bottom of a fraction, so I can cancel them just like they're numbers, just like if it was 2 on the top and 2 on the bottom. Don't get scared by the fact that these are negative exponents. All right, so when I rewrite everything, it's going to be negative 3r to the 4th over, on the bottom I just have r to the 7th. Everything is raised to the 3rd power. All right? And again, there's lots of different ways I can do this, but I look and I see, okay, inside here I have 4 r's multiplied together on the top, and I have 7 r's multiplied on the bottom. So all 4 of these r's can cancel with some of these here, leaving me with only 3 at the bottom. So ultimately what I'm going to have is negative 3 on the top, because everything is canceled away here. On the bottom I'll have r cubed. Don't forget, everything is still cubed. All right, so on the top I'm going to have negative 3 cubed, because you apply it to the top and also to the bottom. Negative 3 cubed, negative 3 times negative 3 times negative 3. If you think about that for a minute, you'll realize it's negative 27 on the top, and on the bottom you're applying this guy. So what you're going to have is r cubed raised to the power of 3, because you're applying it to top and the bottom. So negative 27, you multiply the exponents. 3 times 3 is 9. So negative 27 over r to the power of 9. All right, we're getting close to the end of our lesson here. So basically this will be the biggest problem we're going to do. What if you have 18a squared b to the 3rd c to the negative 4th over 3a to the negative 1 b squared times c, all raised to the power of negative 3. So that's what I have there. And how do I go about doing this? Again, there's 3 variables, different things going on everywhere. There's really a million different ways that you could go about doing this. So the first thing I'm going to do, though, is realize that I have 3 and I have 18. So I know that I can divide those guys. 18 divided by 3, I know is going to be 6. So ultimately, let me go ahead and switch colors over here. Let me open this guy up. I'm going to have a 6 on the top. And then I'm going to notice right away that I have a b squared here and I have a b cubed here. So I can cancel both of these b's with 2 of the b's from up here, leaving me with only a positive b on the top, just one of them. So that's probably enough to do in one step. I could probably do more, but I'm going to leave it there. So the 6 comes from 18 divided by 3, and then I'm going to have a squared times b to the 1st power, that's what's left over, times c to the negative 4 over 3 is gone because I did the division. I have a to the negative 1 times c. The b squared is gone because it was canceled. All this is raised to the negative 3 power. Okay? So let me switch colors. And what are we going to do next? There are a million things you could do next, but ultimately I want to go ahead and just make all of the exponents positive. So let me take my a to the negative 1 and move it upstairs, and let me take my c to the negative 4 and move it downstairs. So what I'm going to have is 6a squared times a to the 1st power, that's because this moves upstairs and makes it positive, times b. And on the bottom, the a is gone, I moved it upstairs, so I have a c, and then I'm taking the c to the negative 4 and moving it downstairs. Make sure you understand what I did. I just take the a negative 1, make it positive, move it up, take the c to the negative 4, make it positive, and move down. And the reason I'm doing that is because it's easier for me to see what to do. In here I have a 6, I have a here and here, so I can add the exponent. So a cubed, I still have a b. On the bottom I have c's, and I can add the exponents c to the 5th power, and I'm still raising it to the negative 3. So I have 6 times a cubed times b divided by c to the 5th power, all raised to the negative 3. Now, you've simplified this so much that I would almost consider this done. I mean, you could basically say, well, you've done everything in the middle, that's done. But there is one more thing you could do to even simplify this further, because you have a negative exponent here. And let me show you how to do this. This negative exponent is applying to the whole thing. So you could rewrite this and say it's 1 over 6a cubed times b over c to the 5th, all raised to the positive 3. You know, I said anytime you have a negative exponent, move it to the bottom, make it positive. So all we did was move the whole thing to the bottom and make it positive. You say, why would you want to do that? This doesn't look simpler. Well, but then you realize you can apply this exponent to the top and the bottom. So 6a cubed b to the 3rd power, whoops, I've got b here to the 3rd power, and then I've got c to the 5th to the 3rd power. And I'm going to show you why this is true in a minute, but for now let me just write down. When you do this, what's going to happen is this is going to go to the top, so you're going to have c to the 5th to the 3rd power, and you're going to have 6a cubed b to the 3rd power, like this. And then what's going to happen at the end of the day, if you want to make it even more clear, is you could distribute this in. 5 times 3 is 15, c to the 15th power. Here you can distribute the 3 for an exponent everywhere else. So you have 6 to the power of 3, and then you have a to the power of 3 times 3, like that. So 3 times 3 is 9, so a to the 9th power. And here you have b to the 3rd power. All right, the only thing you can do left, you have c to the 15th on the top. 6 times 6 times 6, if you do that in a calculator, it's 216. A to the 9th, b to the 3rd. Make sure you understand that this is an exponent. B to the 3rd power up in the top. And this is correct. C to the 15th over 216, A to the 9th, B to the 3rd. The only thing that you might not get by just looking at it is what I did here in this step when I flipped it over. I mean, think about fractions for a minute. This is basically a fraction. What do you do if you have 1 over 4/3? If you have any idea? When you have 1 over a fraction, it's the same thing as flipping that fraction kind of like a trapeze. It flips up over, and it's the same as 3/4. It works for any fraction. 1 over 9/10 is the same as 10/9. You just flip it over like that. So that's all I did here. So I basically moved this downstairs, making it positive, distributed the exponent into top and bottom, so that I freed up this fraction to flip upside down and make it so that it looks normal, because this looks kind of crazy. Everything on the bottom gets moved, and everything on the bottom stays the same, and then I just distribute the exponent in, and you're left with this answer. To be honest with you, you could probably work down to here and call yourself pretty darn simplified, but since there was more to distribute in, you could probably do it that way as well. And by the way, the same thing, I'm doing it this way just to show you, but you could distribute the -3 in to all of these guys, and then down here, and you'll get a lot of negative exponents. When you jockey the negative exponents around, you're going to end up with this at the end. So that's probably a good exercise for you. Apply the -3 to this, apply the -3 to this, apply the -3 to this, just like we do for exponents. You're going to get lots of negative exponents inside. Move them up and down and all around, and you'll get the answer. And in fact, I'm liking this idea so much that I want to do it right now just to show you, just to make absolutely sure you understand. So, different way to do it. Let's apply here. You have 6 to the -3 on the top. You have a, 3 times -3 is -9. Here you have b to the -3. Here you have 5 times -3 is -15. So you have negative exponents everywhere. All of these negatives can go down. All of these negatives can go up. So at the top, you'll have c to the 15. Here you'll have 6 to the +3. Here you have a to the +9. Here you have b to the +3. Notice this is exactly the same thing. Everything's the same. It's just the 6 cubed is 216. So whether you apply the negatives and then jockey the negative signs up and down, or if you do what I did here, splitting everything up, flipping it over, and kind of more steps really, you're going to get the same answer either way. All right, we're wrapping up the section here. Simple problems. X to the 2m times x to the m. How would you do this? The reason we're doing this is because most up until this point, all of the exponents have been numbers. Here we have letters in there too. But the bases are the same, so we just add the exponents. 2m plus m. And we learned from simplifying expressions that we can add these together and make it x to the 3m. So that is the answer, x to the 3m. And finally, if we have something like x to the 3 or y to the 3m plus 2 multiplied by y to the negative m, what do we have? We have the same bases, so we add the exponents. So we have 3m plus 2 minus m, because we're adding it to this. And then when we do this, 3m minus m gives us 2m, plus 2 just hangs along for the ride. So everything is self-consistent. Everything is self-consistent, whether you're dealing with negative exponents, positive exponents, exponents that are 0, or if you have exponents that involve variables. The same rules apply. If you have the same bases and you're multiplying things together that have exponents, you can add the exponents. If you have a power raised to a power, you can distribute it in, and so on. All of these things that we've learned. The only new thing in this section really is that anything raised to the 0 power is always 1. And also, if you have a negative exponent, you can move it to the bottom of a fraction and make it positive. Or if it's already in the bottom, you can raise it to the top of the fraction and make it positive. Those two things together let you tackle all kinds of different kinds of algebra problems where you have lots of complicated things to simplify. And I think you'd agree that when you just thrown to the wolves, it looks difficult. But once you take it step by step, you kind of understand what's going on. So make sure you understand this material, work all of these problems. Go grab some extra problems, work all of those problems. Make sure you're absolutely rock solid, confident in what we're doing here, and then follow me on to the next section where we will continue building our skills in algebra.